Hi, this is Jacob Cooper. This is my Physics 2211 Lab 3 at Georgia Tech. So a little bit of a background here. We have a star that's orbiting a black hole of an unknown mass, but we do have the mass of the star. So we're trying to estimate the mass of the black hole. And then in part two, we're trying to determine the initial velocity as well as the forces on the planet due to the black hole and the spaceship. Our findings, here's our mass of the black hole we estimated, and then here's our initial velocity. Some important concepts. We have our update velocity. We have our update position, net force, momentum, and the universal law of gravitation. Here's our first glow script coding. And so, we have some initial conditions here. We have, our initial velocity, final velocity, same with momentum. Start using those to, get our change of velocity, change of momentum. Here we can see our Newton's second law being used because change in momentum over change in time is just net force. So we use that to, and then, we also get our parallel net force and our perpendicular net force. And we come down here and to get our mass of the black hole, which is we just manipulated the gravitational force formula. In our part two for our glow script, we're calculating all like the force of gravity, all on the planet. So from the black hole and from the ship, and so as you can see, we have a net force on the planet. Here we have a net force on our ship, and then down here we have our velocity and position of the planet, and then ultimately what we're looking for, which is our initial velocity of the ship. So it's our code. You can see the Newton's universal law of gravitation coming in handy here. And then our follow-up questions: what does it mean, and what if? So what does it mean? We want to discuss how the net force and its parallel and perpendicular components are different from the rate of change in momentum and its parallel and perpendicular components. Well, the magnitude of the net force and the change in momentum are equal. However, the components of the rate of change in momentum are calculated from information that is given in the data, while the components of the net force are predicted based off what I calculated for the rate of change in momentum. Our what if question. So that is, what initial velocity would your spaceship need to have in order to enter some kind of orbit around the black hole? Well, I didn't calculate the exact initial velocity, but the spaceship needs to move towards the black hole, so the S component of the velocity should be negative, but it must also have more kinetic energy than the total gravitational potential energy. And that's my presentation. Thanks for watching.